especially to Engineer Janice Pospos. I am Joljin J. Talisayan, and for today's discussion, we're going to tackle the probability distribution. So before anything else, I will present to you the outline of the discussion. First, we have definition of probability distribution. Second, illustration of random variables, discrete and continuous, with each examples, and discussion of discrete probability distribution. Are you ready? Let's start! What is probability distribution? Probability distribution, also known as theoretical frequency distribution, can be defined as an actual experiment observation, but it is constructed through expected frequencies obtained by mathematical computation. Random variables. So, random variables is used to quantify the outcomes of probability distribution. That's why it is important to know first the random variables before we can proceed to the discrete probability distribution, because it's used to quantify the outcomes. So random is a chosen, done without a particular plan or pattern. Variable, a quantity that can have any one of sets of values or symbols that represent such quantity. Examples: age, civil status, y, and z. Random variable. The value depends on the outcome of a random process. So, it can be variable whose value is numerical outcome of a random phenomenon. So it can also denoted with a capital letter. That's why in example in variable we have the x, y, and z, because it can be denoted with capital letter. There are two types of random variables. First, we have discrete random variable. So, it is a variable that can take an finite number of distinct values or countable values. Example, roll a die. Random variable, number on die, possible values 1, 2, 3, 4, 5, 6. Second, inspect parts, status of part, 0 if defective, 1 if not. Park cars, random variable, number of cars, 1, 2, 3, so on, or the n, or the total number or of cars who parks. Next, we have continuous random variable. A variable that has an uncountable number or possible values. So, the keywords of continuous random variables is uncountable, while in the discrete random variables is countable. So, examples: package content, random variable, weight in ounce, possible values, any values between 0 to 1. Next, new hire, salary, possible values, any values between 15K to 25K. So, discrete probability distribution is a type of probability distribution that shows all possible values of discrete random variable along with the associated probabilities. In other words, discrete probability distribution gives the likelihood of occurrence of each possible value of a discrete random variable. Now, let's open the topic in discrete probability distribution. So, there are two properties that we need to consider of determining the discrete probabilities distribution, or in computing the discrete probabilities distribution. First, the probability of each value of the discrete random variables is between 0 and 1 inclusive. Second, the sum of all probabilities is 1. So, it is important to distinguish between the two types of random variable, the discrete and continuous. So now that we already understand what discrete variables, so we are ready to develop, or we are ready in developing the probability distribution. So this discrete probability distribution will tell us how the probabilities are distributed over the values of the random variables. So let's start with a sample. Rolling a die. So we have the outcomes here, 1, 2, 3, 4, 5, 6. As we all know, that die have 6 faces. So probability 1/6. So this table shows the probability distributed for the number ruled. So we can see that all possible outcomes are listed in the probability associated with the probabilities outcomes. So 1/6. So the example here is a discrete uniform distribution. So as you can see on the table, so as you can see here, our probability are the same or uniform. So it is considered as a discrete uniform distribution because our probability is 1/6. All of our probability are the same. So in order for us to compute the discrete probability distribution, we need to use the probability function of x denote the probability of each random. So as I've said, for example, we need to replace the x with the possible or the x that we're going to use. So for example, we have 3. So 3 is the number of die. So equals 1/6 because as I've said, it is uniform. So the probability are the same. So f of x, f(x) equals 1/n, where n is the number of possible values. So it is uniform. So n here is 6. So we have seen listed in the tabular format is called probability distribution for a discrete random variables. So it is a mutually exclusive listing of all possible outcomes with a probability of occurrence listed for each outcomes. So we have another example here, number of orders per day. So we need to assume that we have a restaurant. So our numbers orders per day 0, 1, 2, 3, 4, 5. F denoted by x, it is the associated or the probabilities. So the number of orders are mutually exclusive categorized ranging from 0 to 5 orders, and probabilities associated with each outcomes are 0.05 to 0.05 for 0, then 1 for the 1.10, and so on. So we can take the tabular listing of the orders per day and create a graphical presentation of the data. So as you can see here, we have a graph, which is a graphical presentation. So both tabular, this is the tabular, which is the computation of our data. So both tabular format and graphical presentation show the same data of the distribution of the value, since the outcomes are discrete categories. So this is called a discrete probability distribution. So next, we have the expected value of discrete random variable. So the expected value or mean of a random variable. So use this to measure the central tendency for the random variables. To get the expected value of x, take each possible outcomes and multiply, then add it to So let's try to calculate the expected value of discrete variables. So we need this formula. So expected value, as you can see here in the table or tabular, all are given. So we have our probabilities is 0.1. So we need to multiply, like what I said, we need to multiply the x to each probability. So in a 0 times 0.05, we have 0.00. So after that, we need to calculate all the expected value. So now we get the 2.55. So expected value equals 2.55 per day. So we have 365 days per year. So times 2.55 equals 930.75 orders per year. Variance of discrete random variable. So, in order for us to calculate the variance of a discrete random variables, we need to use the formula of variance. So, x is written as bar or the initial of variance. Our parenthesis is x is equal to the lowercase sigma equals capital sigma, which is the summation sign here. As you can see, there's a summation sign, x minus mu, and the parenthesis squared times the probability function of x. So as you can see here in the second column, we have the x minus mu. Since this parenthesis is the formula for the variance. The third column, x minus mu squared. So we need as our second column are calculated or tabulated. So we need to multiply. So it is the mean. So we need to multiply it by itself. So because it's squared. So and the fourth column, we list all the probabilities that were associated with each columns, or the number of orders per day. So this 0.5 is already given in our example, so we don't need to find it because it's already given. And lastly, in the fifth column here, as you can see in our tabular, we take the product of third and the fourth column. So third and the fourth columns of each number of third columns by corresponding number in a fourth column. So after multiplication or after multiplying our third and fourth column, so we have the product of 0.30, we have the product of 0.325125 and the other also. So we need to calculate it all to get the variance of discrete random variable. So we have 1.647 for our variance of discrete variable. So this is our number of variance now, the 1.6475. So we need to take the positive square root of the variance. Standard deviation for discrete random variables. So after the computation of the variance, we need to proceed the standard deviation. So we have the formula here. So equals square root of 1.6475 equals 1.2835. So the square root of our variance is 1.2835, which is our standard deviation now. So that's all. Thank you for listening. I hope you had fun. That's all. God bless.